Hello students, welcome back to inverse trigonometry functions. In this module, we are going to do a very important problem. What does the problem say? Show that sine inverse of 12 by 13 plus cos inverse of 4 by 5 plus tan inverse of 63 by 16 is equal to 0. So starting with the solution, in triangle ABC, if I say that let theta equal to sine inverse of 12 by 13, so I would get sine theta as nothing but 12 by 13. So sine theta is nothing but opposite side upon the hypotenuse. So when you require the third side, using Pythagoras theorem, I would get third side as 5. So I can say the tan theta is given by 12 upon 5. So the theta, which is nothing but tan inverse of 12 by 5. So from equation number 1 and equation number 2, I can say that sine inverse of 12 by 13 is equal to tan inverse of 12 by 5. So students, make a note of this equation. We would be requiring this equation in the further solution part. Also, let alpha be cos inverse of 4 by 5. In this case, if I say let alpha is equal to cos inverse of 4 by 5, therefore cos alpha has to be 4 by 5. Cos alpha is given by adjacent side upon the hypotenuse side. So the third side is 3 units. We can get this by Pythagoras theorem. So when you know that alpha is cos inverse of 4 by 5, cos alpha is 4 by 5, you can find the value of tan alpha, which is nothing but 3 by 4. So alpha would be tan inverse of 3 by 4. So equating these two equations, I can say that from 3 and 4, cos inverse of 4 by 5 is equal to tan inverse of 3 by 4. Students, you remember the earlier equation in which we had equated the values of theta. Over here we have equated the values of alpha. Both these equations we are going to require now. See, therefore I can say that sine inverse of 12 by 13 plus cos inverse of 4 by 5 plus tan inverse of 63 by 16 can be written as, you remember this sine inverse of 12 by 13 is equal to tan inverse of 12 by 5. I had said you mark this equation. So I can say we can write it sine inverse of 12 by 13 as tan inverse of 12 by 5. Also you remember this cos inverse of 4 by 5 should be equal to tan inverse of 3 by 4. So we can write cos inverse of 4 by 5 as tan inverse of 3 by 4. So sine inverse of 12 by 13 is replaced with tan inverse of 12 by 5 and cos inverse 4 by 5 is replaced with tan inverse of 3 by 4 plus tan inverse of 63 by 16 remains as it is. So moving ahead with the solution, if you observe in first and second term, you have a standard formula. Tan inverse of x plus tan inverse of y is given by tan inverse of x plus y upon 1 minus xy. So in this case, it would become tan inverse of 12 by 5 plus 3 by 4, the whole upon 1 minus 12 by 5 into 3 by 4. So after solving, what you would get is tan inverse of 63 by 20, the whole upon minus 16 by 20 plus tan inverse of 63 by 16 remains as it is. So by cancelling 20, what the equation would be tan inverse of 63 by minus 16 plus tan inverse of 63 upon 16. We know tan inverse of minus x is given by minus tan inverse of x. So tan inverse of minus 63 by 16 would be minus tan inverse of 63 upon 16 plus tan inverse of 63 upon 16. So by cancellation we get 0 and hence this is our requirement. Students, make sure such type of questions are quite common in the exams. So make sure you solve such type of questions. Thank you.